Hey everybody, this is Larry. This is me doing the virtual contest for Biweekly Contest 176, around times day contest. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest. No expectations. Let's just kind of get it done. Let's hope it's a straightforward contest. That's what I'm hoping for. My shoulder's still a little injured, so we'll see how that goes. All right, let's count down. 5, 4, 3, 2, 1. Go, 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 go. Do. Oh, I misclicked one of them. Okay, fine. All right. Your weights. So you sum the weights. Okay, fine. Something like this. Like that, right? IRQ? No, that's not right. This is annoying. It's probably fine. ABCD is 34, 17, 26, 16, right? So minus 8. Oh, wait. What is the mapping? Oh, reverse alphabet. Alright, fine. I was really confused. I was like, I think I got that one wrong, but watch me still make a silly mistake. Okay, that was pretty good, finally, for once. Alright, Q2. Prefix connected if, and this has to be a prefix on A and B, and it, okay. K is equal to 2. Connected, return a number of connected groups that contains at least 2 words formed by the given word. So it's just like you could do it with what you would call it, connected components type things, but we can also just do a try, right? Am I confusing things? I mean, we don't even have to. We could just do something like, nope. Something like this, right? Am I confused? 2, 1, 2. Oh, of 2 or more. Okay. Alright, well, that's just me being dumb then. I mean, but it's still the same idea. That I think I watched that one out because I thought it was like, man, I got it. I'm so smart. But I mean, it's still the same idea though, right? So I don't know. It's very weird. So it's just dot values, right? The input was right, but I guess I just forgot the one case. Let's see. If I get another wrong answer, I'll be sad. Did I misunderstand this problem? K is equal to 1, you have H, so they have one group, right? What am I misunderstanding about this problem? Duplicate strings are treated as different words. Words of length of less than K cannot join any group. Okay. Is there one that is no, though? Yeah, I mean this one actually I got that one wrong anyway, but Man, that's what I get for. Maybe I should have just. Maybe I should have just done connected components type thing. I mean, and I don't know. What am I doing? What am I doing? But also, why is this one? That must. Oh no, I mean this should be one. But why is this? Why am I putting 0? Oh, why did I put 2? What, Larry? What are you doing? Larry, what are you doing? How did that work for all the? Oh, maybe I just saw this 2 and I got confused, but. And I just got lucky with the other, lucky in the other examples. Wow, that is just silly. This has not been a smooth contest. Okay, let's just, it is what it is some days. When you try to be too clever. But I mean, I was right. It's just I did not implement it correctly because I was like, look at me. Okay, anyway, all right, let's take a look at this problem. Nums and colors, length n. Num sub I is the amount of money in I've house, and the color sub I is the same color code. Return I mean, that's still straightforward, right? It's just DP. What are you DPing on? I mean, it's just, yeah, I mean, I don't know. Yeah, I think this is it, right? So you have index. I think this is it. I don't know if that does anything that crazy about it. If this is not the case, then no. Okay, fine. I don't want to write this. This is the case. If they are this, well, I mean, this is gonna be case. Well, I mean, I meant this. Okay, this is the case. Man, my brain is not working today. Okay, so if they're the same, then yeah, then we could just do index plus 2 plus index. And we just don't lock this house. Just also because Leetcode is silly. Oops. Yeah, I thought unless I misread it, that should be fine. But okay, now we have a 7 pointer, so it already is going to be maybe a little bit trickier than average. How are we doing on time? Well, I mean, yeah, Q2 was a little bit sad, but this, I don't know, you have all these people finishing so fast, so smart, in a way that no one ever has done before. Somehow. Okay, you have a tree with edges, that's fine. Given a string S sub I is this character represent, so is there emotion? Oh no, I guess you could have the same character. Okay. Update, okay, change the character. Okay, find a query. Determine whether the string formed by the character is a unique path can be arranged in a palindrome. Okay, what does that mean? So basically you have a tree, you change some nodes, right? And then you have to, whatchamacallit? You have to, so it's almost like a you want, no, that's right. I was going to say you want some like LCIA type thing, but the thing is that we only care about the root of the tree because it cancels out because of the palindrome rearrangement thing. which they've used one time, or at least one time anyway, like maybe a year ago or something. Okay, so that means that for each, so then what does it turn to? Then that means that if we're going to get from root to node, then so um then it's just a binary bit because it's a bit mask on 26 letters. Okay, so that part is easy ish. And so then now you just do an XOR of those two. Okay, that's fine. But then now it's update, right? What do we do for update? Because we have to update the node and the children. So then you just do a binary lifting from the I mean, okay, so there's binary lifting with an update. That how do you do the update on that? I feel like I don't know. I mean, I know. I think I figured it enough to know that I would not be surprised if there was a standard thing to do, but I don't know the actual literature of like there's this dynamic update with binary lifting, like almost like a binary index tree type thing, or of like just updating it every. And how would that work? Because then you just have to. I imagine it would have something like that where your update is like log n or something, and then the query would just be easy as well. Well, log n as well with the binary lifting. I don't know that I know how to do it though, to be honest. So okay, so how would we do an update? Do I figure it out from principle or do I Google? Because it seems like a known thing, but I just don't know it off my head. I'm gonna get a water first though, tell me that. Let's see. Can I figure this out on first principles? Can I? Oh, I mean, I get the ideas, but it seems like it would take me the rest of the time to figure it out. Unless there's another way, but is there a smarter way to collect? Is there a smarter way to update that isn't O of n? Double check the constraints. Yeah, I mean, should I miss anything obvious? I suspect there's like a segment tree component, right? Okay, so what am I at? So if I update a node, what does that mean? Well, I mean, the two updates, one is to remove, one is add, say, but updates itself. But even just starting from that node, there'll be log n. And then there's so many other ones, right? Do I know this? Is this literature? Excuse me. I mean, it feels maybe there's a segment tree thing. No, maybe. I mean, maybe not. I don't know. But it's that kind of texture. Can I do square root decomp? That doesn't even make sense. I don't think necessarily. Those are the only two things I know. Okay. Let's see if I'm. Let me. Binary lifting. Dynamic binary lifting. No, that's not what I mean. Maybe not. Maybe I'm wrong. The binary lifting. Because it changes this node and everything underneath. Is there a way that I can? I mean, and there could be many changes, right? But we're given the query. Can we pre-process the queries? I don't know. And 1,000 people got this one apparently, so maybe there's a more fundamental way that I'm missing. I don't know. Can I do it on each individual character independently and not do it in a bit mask? And maybe do like an O26 times log n kind of way? Maybe? Then what would that look like? That means that we have the one update order ancestors, well, not ancestors, the other way, descendants, that with the toggle order descendants. Is there a way to do that? I'm still thinking too much of binary lifting. And that's the problem. Let me just pause this for now. Okay. Okay. I'm trying to think, maybe we can pre-process the queries. Maybe I'm... doing it in a dumb way? I don't know. Can we have 26 trees? What would that look like? I have no idea. Am I missing something basic? That's the question. How much time do I have left now? Can I do 26 trees? And is that any different from doing a bit mask? Probably not, but okay. Worst case scenario, with a linked list, what does that look like when you update? That's what I should focus on. Okay, you have linked list. When you toggle, what happens? Okay, so well, everything on the subtree gets affected. But how do you process that faster than linear? Well, how you process it faster than linear in a linked list case is by having a segment tree, but that's only that part only works with a linked list. Can I update the query? Can I change the queries in a way that only happens? Can I actually change the queries order? Okay, so what happens on an update? Update basically splits a moment in time. So then now you have a segment. Then you have queries, but you could have a lot of queries. Right? How do I? Can I break? I'm just trying to figure out if I can pre-process, well, not even pre-process, but process the queries in a weird way as we're processing the tree or something. Like we go down the tree, maybe we go down node, we go, okay, well, maybe that's too slow. Was eventually we for each node update for everything. Right. Do we do a divide and conquer? I don't think so. Because of the linked list case. This is not a thing, right? I don't know if I know this one. I'm able to get this one. Even though 1,000 people got it. Maybe it is something that's like standardish. I don't know. I'm getting stuck around the same ideas, to be honest. I mean, there is something I remember, but I don't. I guess this is the part that I don't think I've ever done it, but this is where we're up to now on Leetcode, which is kind of ridiculous. And what I mean is, what's it called? Heavy light decomp. And that's, like, I read this a long time ago, but I don't think I've ever used it. And Leetcode is just, I don't know. I don't know what the hell, I don't know. I'm sick of Leetcode doing stuff like this. It's just, like, not interesting, right? It's just like, I don't know. What are you a platform for, Leetcode? What are you a platform for? No one is interviewing with this crap. In case you're wondering, sorry, I'm reading this. It's been a while. This is something I've never done or implemented, but I remember, like, well, I mean, I was like, wait, is it like some crazy things? And the next thing you know, we're gonna use like one of these other things as well, and it's like, well, is it that interesting? I don't know. But now that I reread it again, I'm like, this seems pretty straightforward. In terms of, like, if you knew it and you have code for it, then this is pretty straightforward, and this is just like silly, honestly, right? Like, is that like, is this Leetcode level things? I don't know, but I guess we'll see if I can actually solve it. We have another hour. I don't know. I guess it is like a similar idea to small to large, which I was thinking about. I don't know. Not quick enough, but it's only 42 seconds. I don't know why. I mean, I know why this works. I don't need animation, but uh, this Yusako guide is not very good. I mean, I don't know. It gives you enough for you to research more on yourself, I guess, but it's just not you know. And one thing that, I mean, I thought that I don't need this only because of this palindromic thing, and this palindromic thing means that you could do things on the root versus like on a thing, but yeah, I don't know. Okay, I've never implemented this beside. We'll see how it goes. Okay. I mean, like, I don't know. Like, is this guide actually useful for anybody who hasn't already used this? Because I feel like they just like they don't tell you how to do these things. They're just like they support both. Also, there's some definitions and then some properties, and then that's it. Like, can you like explain a little bit more? I don't know. There's like nothing in between. I don't get it. Like, I don't even want to look at the code per se. Like, I just want to actually understand which part about it. But yeah, well. Eh, I'm gonna see if I can find other resources. Oh, there you go. Because I don't. I mean, I don't care about their implementation. And just for the record, I guess now the rest of this session is just gonna be me trying to learn this thing. Because I don't know. I mean, and then try to write in my own code. I don't care for the other ones. But okay. And then this is like hyper specifically mathematical. Okay, it's fit the. I mean, I know this part. Okay. Yes, yes. Okay. What is the K? Hmm. For each, can I present S of C? Okay, so we have heavy edges. Okay, if it is greater than 2. Okay, it's not so bad to understand. It's been a not that I didn't remember this, but I'm trying to like figure out how to implement this, and I don't want to look at existing code, at least until I struggle a little bit more. And then basically for each node, you calculate the thing, right? And then when you update, what happens? How does updating work? I mean, okay, this is decomposition, and we could do the query part. I could, just looking at this, well, not looking at this, but looking at this part, or this part more specifically, I got a bit. And how to do query. I mean, I know how to do queries, but how do you do updates? I mean, this is literally exactly that, I think. Except for you could say it's the XOR sum or something. You don't even need to XOR sum for the palindrome for this one. You could just actually literally do this. But by building segment trees on heavy paths. Oh, that makes sense. Okay, that makes sense. That's what I was actually. I mean, I got that part kind of independently, but I just didn't put it together because I've never done heavy light decomposition, to be honest. So yeah, because I was just saying like you can do that, but how is that fast enough? That's just so much constants, so many constants. All right, well, YOLO. We will see how much I actually understand. I mean, the segment tree part is like I already came up with it, but with the segment with the when we were talking about linked list and how would I solve this if this was a linked list? Well, and then I kind of talked about segment tree. So that's basically that, and I just missed the part about heavy light decomposition in which so. Yeah, in case you're still watching, this is me trying to live learn HLD, heavy light decomp, right? So bear with me. Like I'm no longer caring about the contest time, which is the beauty of doing these virtually. So yeah, so bear with me, and the code may be a little bit messy as we saw, but okay. So then now, so it's funny because we were talking about linked list. So that was the piece I was missing, because I know how to solve it for a linked list because I figured it out without even. I mean, apparently it's a standard thing, but I'm happy that I figured that out. Okay, or it's like an idea that I have. We just have to do it with heavy decomp, right? So then now we need a segment tree that does range. So it's log square n, yep, and we have to do it for range. There's a lot of implementation. I don't know if I could get this in time. So it's going to be range update. Yeah, range update and okay, range update and range query. Okay, this part I don't want to do from scratch, but I have it somewhere though. And we use XOR. I mean, we could create 26 trees, but there's already a lot of constants. So okay. I mean, we already don't have the standard segment tree. Oh, we have the standard segment tree, but we don't want for XOR. So let's see, right? Let's push update. Okay, fine. So this is the sum version, right? Is it? I don't like. I think I have another version somewhere. I don't like exclusive bounds, or like just to be consistent. So I asked ChatGPT to convert this for me. To yeah, okay. Because because that's just a template that I have somewhere, but I actually want to modify, right? Because now this is the segment tree, this is the plus segment tree, right? So this is the sum segment tree. What we want is an XOR version. Push, what would we want push to be? I mean, it's not a value. Wait, what is this? Oh, this is node. Oh no, this is just push, but okay, let's update, right? Update LRV. So we want to update it to I guess we just toggle, right? So V can be, so it's just an XOR, assuming that V is a 26-bit number. Okay, and then everything here is also 26 bits things. Okay, so then now it's just a regular XOR thing, we just have to be careful. Okay, so what does that mean? So that means that tree, we're given a V, is also that, right? Update. This is then now. Pretty simple. Actually, I mean, I guess some is pretty straightforward to transfer into. I mean, this is actually crazy looking, but we don't need to know the range. Wait, do we need to know the range? Push. No, I think this is fine. If not, then I messed up anyway. So, okay, I think this is mostly fine. Update, combine. Okay. Query. I mean, this is clearly wrong. And that's it. I think we're good here. Then, so that's my segment tree for this problem. With and then now I have to do the heavy light decomp, right? And that's not that bad. I mean, okay, so this is my attempt anyway. Right, I just write out the standard DFS, right? Okay, so that's the standard DFS. And then we can get heavy is the why did I keep that window open for CP? Wait, did I show it on screen? I actually forgot. I don't know if I just closed it or I have another window. Alright, let's see. Huh. I don't remember I showed it. That's if I didn't, that's my bad. I was using CP algorithms. Okay. Okay, I guess this. I was trying to figure out like what is the case if there's no heavy edges, which node 5 here highlights for me. Okay, so then now we have, let's just say, let's have this return the number of total nodes, right? So kind of, right? We have maybe nodes. M is it? And my neck. It's very sore from all the snowboarding. Actually, nodes of node is equal to no. Nodes of V is equal to this, and we don't need total then, right? Nodes of node, right? Yeah, I guess I don't even need this. I can just do this. One for one node, right? Okay, and then now we just go through it again. If nodes of node is less than or equal to nodes of 3 times 2. It is, I guess this, oh no. Why is this at most 1? Couldn't there be 2 that are? Which one is C and which one size of the subtree, including itself. Oh, including itself, that's why. Maybe. No, yeah, okay. I missed the including itself part, so I think that makes sense now. Okay. So if this is the case, heavy edge, right? I don't know how to set this up, honestly, but I guess we'll see. Actually, I mean, implementation-wise, anyway. So we could if we find the heavy ones, right? But how do I set up the? Okay, how do I want the data structure to be? Well, we have the parent, and we have to go through. Let's also cache the parent because yeah, we just kind of need it, I suppose, to go up in the HLD. Okay, so now we have this is in heavy edge. What does that mean in terms of how do I set that up? This is a heavy edge. We already processed that nodes, right? So that means that this is going to be part of that, right? Well, like I'm just trying to figure out implementation wise. Like I get the ideas, but I'm trying to figure out how to cleanly do it in a fast-ish way. So that's how I really learned HLD. Okay, so I think it should be. Maybe I'll just have to pre-process it again later. Okay, fine. Oh, not pre-process it, just process it again later. Maybe that's fine. Okay, heavy edge. So I just say and then we go again later. Okay, fine. Right. And then now so now we have basically heavy is almost like you could actually create a linked list like I was saying, but heavy does that for us kind of. So then now we have I don't know, maybe something like this. So if not done of I, no, this isn't the right way to do it. You can't do it this way. No. I mean, maybe we need to do it through the tree as well. You have to do it this way. Yeah. Good, okay. Yeah, just to do it recursively, but also, okay, so the way I'm writing this is not very clean, honestly, but it should advertise out to be the same, so I think it's fine, but definitely not the ideal way. That's okay. We're actually solving this, we're actually learning stuff, so if done of node and now yeah, we want to say yeah. No. Okay. Or something like this, right? And then yeah, I mean, I don't know why. I'm trying to think whether I need this first one. I think now for items, first label them is done, and then we also want to do heavy root of item is equal to node. How do I do an update? Maybe I think the way I'm thinking about it is wrong. I mean, or not, but the way I'm thinking about it is not necessarily wrong. But I don't know how to do that fast. Because an update, I was going to do one segment tree, and then maybe I've log in segment trees, right? Oh no, okay. So you don't have to worry about those things because you're summing up all the queries. Okay, no. I think this is right. Okay. It's tricky, but right. Okay, fine. I mean, we'll see about that. But I mean, even if it, I think there's a good chance it may time out just because Leetcode's Leetcode. But if I solve this for correctness, I'll be happy. Then we could use template code in the future or something. But I am trying to learn this. Heavy root. Okay, so then now this should be fine. And then now, maybe I do have like st is equal to, okay. And then now, maybe I just put a indexes thing just for lookup. Basically, like I'm treating the segment tree as a node for the linked list or whatever. Okay, so then now we need a new segment tree here. Tree of node is going to be equal to tree. We have n items, so that's length of items, and then just items, right? For the indexing. I mean, we just need it for lookup. I mean, we'll have to do the math in another place. Okay, and I think this should be good. Let's see if we run into any errors for now first. Okay, I mean, this is actually surprising. I thought maybe some of these things will happen. But before I congratulate myself, let's actually make sure that it creates segment trees first. So okay, so it does actually create segment trees, whether it's correct or not, you know, we don't know. But so it's not like it's doing no op, right? If it was doing nothing and I'm just like pretending it works because it did nothing, that's another story, right? But you know, for these two, so actually, let's see, right? So just auditing, this one would have one heavy, or actually one full heavy edge or whatever. And then for part two, there's none of them. There should be at least one, maybe? No, I guess that's fine. So you just have it just by itself. Okay, fine. A segment tree of one element, maybe technically, but maybe I have to handle it. I don't know if it's easier to do it with a segment tree of one element or the other way, or special casing it, and it could go either way if you ask me. But I mean, I haven't done it yet, so okay. So then now we have all these things. Then now we have to do updates and queries, right? So for a query is a string. Why did they put in a string? Anyway, okay, fine. I guess they both have. Oh no, whatever. We could use regex, but it's fine. What is query is UE? Okay, let's focus on the processing first. You see as you go to, I guess this part is mostly the same, and you as you go to, that's what I meant to do. Okay, let's make sure this compiles. Okay, I say compile, I know it's not you know what I mean, kind of, just make sure that this line or something is not something weird, and this should always run. All right, so we actually processed the tree, but we haven't done anything yet, so we actually have to set up the initial thing, right, which is that the string. So for C, index C in I'm actually pretty hungry. Should have maybe ate before I started this. I didn't expect this to be so crazy. I mean, it's not that crazy. It's just that it's new to me. But it is crazy for Leetcode, right? But okay, so that means that we want to update. We want to set an update to the descendants of index to C, right? To XOR 1. So okay, maybe I need a helper. So actually it's probably good to have a helper anyway. So maybe we have a toggle helper, right? So here we have toggle index C. Maybe that's all I need, and that's what I need for updates anyway. So we have toggle U is just the index, right? Yeah, so something like that, right? So we have index C. So that is actually done if that works. Okay. So then now we have to find the thing, right? So okay. So current is equal to index. Okay. Update the current heavy if it's part of it, right? No. Toggle that goes downward, right? And we only have to update because we query the sum of all the queries. We only have to update this one. So actually, it's not that bad. I keep on thinking that I have to update more than that, but okay. So if heavy, maybe I should do like if heavy wood is none, then it's about item of one item. So then here maybe we have a single is equal to maybe just 0 actually, right? So heavy root of so then we don't need the current because we don't need to go up the tree for any reason. Is none, then that means that we have a single. So then single of index to do one. This is a character, right? So that's not right. But okay, just say D for I don't know what D stands for, but right. That's fine. Okay. Otherwise, we do the segment tree thing, right? The segment tree of index. No. So then root is equal to heavy root of index. Then now the segment tree at that root, we want to get the current index. So we want to write something like what do I call it? Update, and we want it to be the suffix. And do we always update the suffix? I guess we do, so we don't even need R. We can actually write R is equal to self.n, right? Yeah. No, it's exclusive. I mean inclusive. So n minus 1. Okay, so that should be fine, right? That part. But now we have to get the index. So this is where for lookup means, right? Okay, so then now, where did you go, code? Where did my code go? Oh no, it's here. So, oh no, the other way, the other one. Come on. So then, and maybe this could be part of the update, but yeah, maybe. Okay, let's do it. Right. So then now we have update index to C or to D, and then now with update, right? So L is actually go to self.lookup of index, and that's it. Actually, I mean it doesn't do anything, but at least it doesn't fail, right? Let's make sure that it does something. Toggling, yeah, okay. Okay. We have to set up an answer for queries. Because now the answer to the other thing. The query part may also be a little bit tricky. What are we doing? So okay, so this is the meat. We're going from the root. Well, okay, root to the node or the node to the root. And we actually could do it from the LCA, but for this problem, it actually doesn't matter, so it makes it a little bit easier. But yeah. So this is let's just write answer that append query UV, right? Maybe. Yeah, okay, let's just keep it this way. We'll just have helpers. Why not? We have index 1, index 2. I don't know. Right. And then we could just break it down to yeah. Okay, right, and then now whether this is if all that bit count or something like that is less than equal to 1, right? That's the palindromic part. Just make sure that this runs real quick. I forget if it's bit count or that's what I mean. Query UV. Do I return true false? Oh. That's what I forget for naming things terribly. Naming things is all I'm trying to think, sorry. It's good, fine. I don't know. Naming things is a crappy name, all right. But I'm Boolean has no oh that bit. Oh, this should be, I don't know, just whatever, 0. Yeah, that's what I mean. That's the part that I was actually trying to test, but I found a lot of different things for it, right? Okay. So then now we just have to update this part, which is, we have 26 minutes left, by the way. How do I do that? Yeah, so then this is the part we have to do. Current is equal to index, right? So while was it parents? Did I call it parents of current is not none. No, you don't want to do current that parents are current. Okay. Then now we have to do the loop of if heavy root of current is none. Didn't I have something like this? Yeah, okay. So we have a single and y is equal to 0, say y single of current, and then current we set it to parents of current, right? And then we keep going. Otherwise, and current is equal to parents of index, where, or maybe just call it root to be consistent with this part, kind of. Root is equal to heavy root of current, and then we go to the parent because this chunk is done, right? And then that's it. No, it's not, I know. We have to do this part of we is equal to st root of query left right. So it goes from the root, so 0 to current, and maybe we should just do current, right? Because we will just modify it the same way. There's no L because L is always 0, because it's always prefix, and then R is equal to self.lookup of index, and it's called this index, right? Something like that. Hopefully this is right. Oh, it's not. Oh, it should be, but if it's infinitely looping, then one of these is wrong. Well, just that parents. Oh, his parents is -1 because the way that I wrote it, so it's never gonna be none. That's fine. Maybe there's other things. But I think the idea is right. Maybe obviously the implementation is wrong. Well, the idea I didn't come up with, so but that's okay. Okay, so let's appointment. What? Let's see. What's it stuck at? So we do a query. Current, we update the parents. This should be right, and this is kind of trivial. -1. Oh. I did the parents. Actually, that doesn't even make sense. Okay, fine. All right. True, false, 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 true. I mean, got this one right, but true, true is not quite right, obviously. Okay. Why? Alright, well, this part will take the rest of the time because debugging is probably going to be a mess. So 0, 2, 0, 0. I'm trying to think whether that makes sense, but maybe that's fine. 0, 2. So this is 0. That's not right. It should not be 0. 0, 0 should never be 0. Is this inclusive? Because we definitely have stuff here, right? Or do I not set it up correctly at the beginning? The 1 is not right either. Wait, actually maybe it is because, well, no. This part is also not right. Even though it gives the right answer. How do I feel about this? Well, 0 is wrong, right? So Q of 0, current is not -1, so then here we have, oh, I'm dumb. Okay, that is bad typo. Wow, if that was it, I mean, I hope that's it, but that's still a dumb typo even if that was it. Oh, actually we should keep the print. Let me audit it. 4 is 4, right? Yeah, and 5 is also right because it's 1, 2, no, it's 1, 2, 4. It's not 5, right? 1, 2, 4 is 7. Why is it 5? That may not be right. Let's see, 1, 2, 4. So this is right, but update is. Oh, that's right. That's right. I forgot a part. Okay, so we would have gotten a wrong answer. We have to toggle the other thing off, right? So yeah. Silly language. I remember thinking about it much earlier on, but this is how I remember it. But I just forgot. Okay, but this part is easy to fix. What is it? S? Okay. So let's convert this to CS for current string, is equal to list of s, right? And we already processed this there. So then we toggle to turn this on. CS of u is equal to c. We update it, but then the previous is equal to cs of u. So then we also toggle that off. And what we need is a toggle. Okay. Where's my print statement? Why did I take my print statement? That's not great. Oh no, I just, okay. Commented out, which is really easy. Huh, still 5 though. That's still not good. It should be 7. Let me make sure my toggle is right. Okay, what we, yeah, this is just initial, and then we toggle off an A and we toggle on a B on index 1. Should be true. And then why is this 5? I just want this to be done. I'm so hungry. And possibly we're close, but we're still not there. Whether we're close or not. Is this? It's 0. Zero and then 1. That's wrong. Well, the 0 is wrong anyway, because we don't summon the 0. Yeah, this is wrong. How did this get right? My watch is complaining it's running low on battery because okay, let's see. This is wrong. 0, 0 should not be 0. And maybe that's the reason? I just got lucky because I don't know. Why is this? Do I just not? Am I using the wrong one? Query index 0, 0. Is there some weird thing with 0 that like I should be like, is this one indexed and I just kind of messed up? Or maybe the update is wrong. Well, no, it's a single. Right? And toggle, we toggle it correctly, right? Huh. No, this is definitely a single. So why is heavy root? Oh no, it is heavy. It is not a single. Wait a second. Why did I think it was a single? I know I misspelled heavy somewhere. Okay. But it should not also be... Yeah, I mean, that's fine. Wait, no, it's not. Oh, I am dumb. I did this afterwards, so then it recurs in a bad way. Oh, I have to do this first, so then it doesn't recurse. Oh man, that's why. Hopefully, okay. Well, now this is 4, so we have to have more debugging, but at least this should be slightly more accurate, maybe. No, it's still wrong. It is heavy now, right? Let's see. Oh, that was so dumb. Okay, so 0, 1. Okay, I guess that's fine. I thought it would maybe 0, 1, 2, but why isn't it 0, 1, 2? I'm missing an item on the thing. If it's not none, then it should be that while current is not none. Yeah, okay. Does this at least fix it? Nope. I don't know what my things do anymore. Okay. 0, 2. I don't know what my debugging is anymore, but at least this should be right. Yeah. Point single. Okay, so toggle C. Do I do toggling right? Oh, this is dumb. This is do. That's why I was like, the 2 doesn't really make sense. But okay, so there's a couple of silly mistakes. Do I have to write our answer? No, still no. I hate you. Okay, but okay, now this is wrong. But we got the 0 to be correct, but this is wrong. Why? Toggle. Oh, maybe it's the update, right? I don't know that I fixed everything. Update value, right? Update value, XOR, push, XOR. Should be right. I don't push. Do I add in any place? That's the thing with adding, is that like it's hard to spot adding that is legit, say. I think that's it though. Let me take a screenshot before I lose it. But what am I doing? Oh, so hungry. Why is this? Oh no. No. Is the update wrong? So update, we update. Well, no, I mean the query is from this node to the root. Okay, so A, this is right, but this is wrong, right? Why? Have to maybe do this. And there's no single, so maybe we could take this out for now. We want to put this in the toggle. Where's the toggle? Or in the initial toggle, where we have a for loop. We have here, right? Yeah, that's annoying. This window is too small. Okay, update A, and then now this doesn't change anything. Why? It's a toggle, right? Did I implement toggle wrong still? Oh, it sets it. Do I set it or do I update it? Update. No, I mean it's not a setter. So why? Do I have a setter somewhere that I forget? No, that doesn't make sense though, because if I did this, then this would be wrong. So C is a 4, so that's right. I'm just not toggling off for some reason. And here it's still not toggling off, it's just changing it. So this feels like a set. Is this like we can maybe do, for example, I don't know. I mean, okay, maybe my segment tree as well, which would be very sad, but or maybe the indexing as well. Updating 0 2 re 1 2 re, that makes sense. No, everything's here is right, or this one's right so far. It sets it to, we audit this, right? We have 8 minutes left. I feel like I was so close to getting it in time. I mean, we still get it, just not in time, but still, I thought I was able to do it, but oh well. X, left, right, X. I don't get it. It's so hard. So close, yet so far. Don't really have time to audit this, but it is what it is. Why are you not working? Is it segment tree? It feels like it's a segment tree then, right? Because it goes from dit to dit with no reason. And it didn't, I don't even know if the toggling off works, because maybe there's a 0 checker somewhere. Did I check something with 0 and maybe that's why? Like we do this thing. Maybe this is the thing. Because we assume that we don't push the 0. But no, but that just pushes, if it's 0, then we just push this down. And it just XORs nothing, right? So why would that matter? It's like adding 0. It shouldn't matter. I mean, it doesn't propagate, but it doesn't need to. So, why is my segment tree? I mean, it updates the B correctly, though it also doesn't update the C, because in this case it would be 7. So there's something wonky going on, for sure. That's why I get for trusting templates. And I have to like audit everything, and I don't even know if it's a template or me. I mean, all the things I'm calling seems to be working, or like I'm calling the right things. So I'm really thinking it's the segment tree. But I don't know how to debug this. I mean, I do, but I'm just not in 5 minutes. I don't think it's my point. Why? Is this even right? No, this is not right either, because it should be just 4, right? So why is my toggle wrong? No, we called update, right? Where's the update? We called update. I think I added a checker here, right? mean, do I have to really debug this segment tree? Yeah, we call it updated with 1. Fine. What is X? X is the node, right? Yeah. One, 2, 1. That's right, right? Updates it to 1. Why? What is the left node and the right node? Right node is 0, left. Did I push it both? Maybe I push both left and right, but it doesn't. I think the X. No, that doesn't make sense. Because if it's a plus, you would still do it, right? It is what it is. Okay. There's too many variables. I don't know which one's right. Okay. Look at this one. It's gonna be. No, we want to look at this one. 1, 2. We're gonna change update to 1. X is 0, which is the root. The root is fine. No. Is it? No. Oh. No. I mean, the query. Okay. I think the root node should have 0. And that would be fine, right? But it's actually 1, so that's also not fine. Oh wait, maybe not here. Actually, maybe after this. No. This is part of this update, actually. So no. This should be 0. Why does the root node have segment tree? Okay, left, right. That's what we're updating. Value, the current X, which is the root node, of 0 to 2. 0 to 2 at this point should, no. This should be a 0. 1, 1. No. 1, 0. Wait. LRV X. Oh, okay. 0 to 1 should also have a 0. Yeah, I mean, I think it's basically one of these nodes should not, like, I think the thing is that in this push, we update it. But we update it for a range that doesn't make sense, maybe. That's why. I don't know how to fix it in like 2 minutes. I mean, we can fix it. It's fine. This is what happens when you use template code, is that it makes some assumptions that I think are not quite right. It doesn't make sense though, but because if you add them, I don't like what would be different if you add them. Like maybe it just doesn't work even for that case. I don't know. Because then now the left tree is, because we update the left tree on push. Should we? No, we should. That's, Yeah, no, that's fine. But why do I have a mid here? Oh, we just ran out of time. That's why. It's not. I mean, the template was right, but it had something that I just remembered. I don't have the window where the template's up, but it was something like whatever it was. It was self dot whatever. Well, because the old template was something like right, but it wasn't just this. It was this times like rx minus lx plus 1 or whatever, right? But this would be 0 or something. So that's why. Or like mid rather, not lx rx. But that is so dumb. I'm so dumb. This is what happens when you don't think through everything. Okay, so the left is lx and mid, right? So if mid minus 1 and then rx minus mid plus 1 then. Alright. I don't even know if this is gonna be fast enough, but it was the segment tree. But it wasn't a segment tree template. It was just I kind of yeah went for. Wait, actually, let me double check real quick before I say anything. Right. Okay. So after 1, is this right? This is still wrong. It's giving me the right. Oh, I was looking at the expected, and I was like, oh, expected is right. But actually, no, my output is still wrong. So that, I mean, what is going on? What is this like clicking game? I'm just, what is, what? Why is this now here? Oh, I hate Leetcode. I just, what is going on? Let me see if refresh fixes it. Nope. Okay. So it's still wrong. But that was definitely, I mean, maybe that is part of it, but that's why that part is wrong. Okay, we still have to fix that though, because here you can see that it's still wrong, but I think that is part of it. Or maybe I just kind of have, yeah, maybe this is still not clean enough. All right, let me look at my, let me see if I can find my template that I used for this one. And because maybe I changed it without thinking, right? So it was something like this. Oh, and also this is off by 1, I guess. Maybe that's why actually. Nope, still wrong. Is it still wrong in the same way? I don't know. But the old code was something like this, and I guess this part would be this part would be 0. So then that's why it doesn't do anything. Now to see whether we have other things that are like that. Let's just put the lazy things on there as well, because maybe that's just weird. I was hoping that would fix it too, but you know. But yeah, it seems like the segment tree is definitely wrong, right? That's probably why. Which, not great, but at least. It's not terrible. It should be 0 though, because the left of O of 1 should be well, this update is only for 1 and 1 to 2, so you update O of 1. I think I'm also confusing things. I am confusing things. Okay, so I'm actually wrong here. because I actually do a range update, but it's actually a point update. Because we don't update the suffix, we just update the point, and then the suffix get part of the query. Okay, but that's easy-ish. So because then now we just kind of do yeah, update 1 point in a sec. Still very wrong. Okay, let's see if it's at least consistently wrong. Okay, this is what we expected. This part maybe not so much. Oh no, this is right. No, this is right. Okay. Oh no, this is right. So why am I getting okay? Well, one step at a time. So I actually had a very fundamental misunderstanding of what my update should be. And this is actually applicable to every HLD. So I mean that's fine. You know, like this is part of the discovery. But why is this wrong though? I mean the tree now seems to be correct. So now we have to figure out why that is wrong. Okay, let's say let's look at the D. How many D's are there? It's this one. 1 and 4, so that's 5. So that's going to return false. From 0 to 2 inclusive. Oh, because then now it includes the root. Yeah, it double counts the root. I guess that's what I mean because it overlaps. Okay, that's fine. Yeah, I see. It is a little bit awkward, but that's fine. Yeah, okay. And it sucks because I can't raise my left shoulder as quickly. But yeah, yeah, okay. Now that was actually an easy fix. But now let's remove some things and then see if it solves itself. Man, I have a lot of random debug statements. But it did help, just, you know. Yep. Did I put in uppercase? Oh. This one is fine. There's still one more print statement, or maybe 2 more. I don't know. I don't even know where they come from. I have too many print statements. Oh, there it is, actually. Okay, that's YOLO submit. We are after the contest, but there were a couple of silly things. Okay, we have a wrong answer. This seems like an easy one to debug, or not easy one to debug, but at least you can figure out why. Oh. No, I was gonna say we didn't sort it. But I don't think it matters for us. From 1 and 2, J is FJ. We put true as false. 1 is gonna be okay. Let's see. And we could just reuse this, I think. My shoulder is so bad. Okay. So you have 2 at 2. There should be 1 J. What is J? A, B, C, D, E, F, J. 6. 2 to the 6 is 32, I guess. I don't know how you get 554, so maybe that's the that's the reason why. Also, let's just do 512. Huh? A, B, C, D, F, J, H, I, J. J. Okay, so that's a J. Yeah, I mean, that makes sense. Okay, so you have J, F, J. So what is R? That is confused. Okay, so JFJ is fine and FJ is not fine, right? And F. Oh no! Wait, maybe this hack is not right for stuff that doesn't include the root. Because okay, so right? You have this thing and then this thing, and they include the root. But if the other intersections don't include the root, then you don't do Q0, right? Huh? That's actually wonky. Okay, how do I fix this? Do we double count? I mean, they should cancel out. They cancel out everything except for the LCA, so we need the LCA. So and I put 0 because I thought that the root is fine, but it turns out that that's because that's the LCA of the root. I don't want to plug in LCA. So we're not done. We still have another, like, I don't know. How do I want to do? I can't believe there's still more. I need LCA for this. Do I? I guess so. I mean, it's not that hard, but I'm just tired and lazy, and been an hour and a half for this problem, and just so much debugging so far, right? So okay, fine. Right. I'm fine. It's so annoying, but we already have parents, so I guess that's good. What we need is just TP. I hate you. Hate everything about this. Okay, let's put it here then. I'm lazy. Okay, so then so we want something like that. That's not how you call anything in maybe I just write like this actually. So then now okay, maybe I just write okay, right? Don't know why I need to do this. I forget. Okay, let's just do it without it, and maybe we'll get lucky. So then now j is equal to dp I minus 1 j, the parent of that, right? Something like that. Right? How do I do this again? It's just okay. Then I mean I know how to do it. It's just so annoying. Okay. So then for each node, how do I do it? So okay, so you have something like if something like this. Wait, I have to do like some ancestor stuff, right? I forget. It's been a. I was not prepared for this. I have to think about it. Okay, so this gives me the pen thing, right? Man, I am forgetting. Okay. How did I do the ancestor check? Wow. Huh, how am I forgetting this? Wow. Maybe I'm just too hungry. Wow. How am I forgetting LCA today? Huh. Wow. I mean, I get the ideas, but I'm trying. I forget about the part where I'm gonna get a shake. I'm forgetting about the part where how does it do it in O of 1? Huh. How does it do the part where it's O of 1? I'm okay with looking up heavy light decomposition, but I'm not, for now, I'm not okay with looking up LCA because I should know this. Oh, Lydian Tor. Fine. And there's just so much stuff. And they're all template. And they tell me that someone could solve this in 4 minutes. Or maybe it's a known problem. But yeah, okay. I remember now. No, it's not that. Oops. Where did it go? No. Where did it go? What's it called? I forget what they call it. Let's just go entry and exit. That's right, that's right. E4 Lillian. No, you can probably put this in here on the F. But man, I am. Oops. I don't remember what I'm supposed to implement for this one, but I think implementing is a safe thing to do anyway. Okay, and then now an ancestor. Man, I can't believe I forgot that one. But Then now if entry of B right, that's it. I hope I'm not missing anything. That's fuse, right? Just in the subtree, right? Yeah. Be okay. The equal signs are probably weird, but whatever. Okay. So then now, yeah, it's like if ancestor of if the current node is the ancestor of A. Oh well. Am I supposed to go downwards? I think I'm supposed to go downwards. Then we want something smaller so nothing happens. So then if not, something like this. Well, if it's an ancestor, then we don't. Wait, let me figure it. Okay, so here, no. The first one's gonna be all of them, so it'll always be true. And now we go to. Oh, we have to look at the next one. That's why. Okay, fine. Is this yes? To yes. To no. If it's a no, then we go up there and then we count again. Okay, fine. I mean, I know they probably could have templated it. I have written this enough times, but I forgot about it. It's been a while. Oh, this could be -1. That's why. Yeah, okay, fine. This is in the pen. That's why I wrote it this way, but I forgot. I thought. Oh, oops. I don't know how to program. It's called negative. Am I messing this up? Okay, so dp sub I, and this should be. I think this as well, actually. It should just go up to the root. Okay, now everything's well. We could find out what LCA is, and that's why. And maybe I just do -1 as LCA, is that right? Yeah, that's what I suspected. Also, my binary search as well. That part I actually didn't feel right. I think the other stuff should be right. Yeah, repeat doubling, yeah. Maybe this is this, I don't know. Maybe I'm off by 1. But, well, it's still -1 as the LCA, which is definitely not right, so it's probably the binary search, right? Okay, let's go AB. This should never happen, so that's definitely not right. How did I get? Yeah. maybe just if dp of ij is equal to -1, just set it to the root. I mean, I usually default it to 0, that's why, but maybe not in this particular file. Still wrong though, I hate everything about this. Maybe I should just template it. I've done this millions of times, maybe not millions, maybe like tens, I tell ya. But it's okay. Checking 0, 2. Checking. Okay, finding. I guess it's whatever. But okay, we're checking whether 1 is the 0. It's not, so then we set it to 1. Right? Something is wrong though. This should be 0. Did I mess this up? On the DP? No, I don't think so. So what? This should be 0 on the first iteration. Because I is pretty big. Did I mess up an index? No. I is pretty big. Why is everything a struggle today? Okay, so these are the parents. These are the parents' parents. But something is wrong. Something is wrong because this is -1 and it's confusing this, I think. I think what I needed is not this part. It is this part. Yeah, this is when like so poorly. And my eyes are tired. My everything's tired, but also my eyes. But okay. Find 0, 2, 0. Okay, so it is an ancestor. I'll try something smaller. Why is this 4 for 3 items? You might need that, but it seems like a lot, right? Yeah. All right. Check 1, right? So then now what's LCA? All right. I think I did the binary search a little bit off. I think we need to return the parent. That's actually the node under the LCA for my binary search. Okay. So at least it fixed for this, but not this, right? Because there's a -1 already. Why is there -1? And there should never be -1. You should just If this is -1, oh, then the parents, this is very awkward. I think I could have just solved it by saying like, and then we could go back to -1 later because I think I used it for something else, assuming it's -1 and going to the parents thing. Okay, so this solves this a little bit. Let's see if it actually does. Checking, check. 0 is okay. I mean, it's better, but so parents and parents. I mean, I think this is right. Parents and parents. Did I miss something in my binary search? No, because it's returning 0 as the LCA, which is definitely not Oh, maybe now this other thing is wrong, that I do the parents thing. Because I just kind of assumed I could return the parents over. Wait, that was my binary search. Yeah, maybe I don't need this anymore. Really? Really? Why? Is my binary search wrong? It's probably wrong. Why am I not getting binary search today? Why do I have an extra LCA? What is going on? Where's my LCA? It's too much code. Okay. Binary search. DP is the DP, right? I forgot. No. No, I mean, this is right, actually. DP should be right. The binary search tries to node. Nope. Two, one, right? So that's good. So 0, so that's true. Okay, let's slow down. Okay, so it's binary search. It's this ancestor, yes. If it's this ancestor, then we try. Oh yeah, I think this is where I'm getting wrong. Right, it's trying to find out which half. So given the I, then now trying to find the top half or the bottom half. If it's this is in yeah, the bottom. If it's not in what? Wait, okay. So you have this half. Or okay, so not half, but okay, so you have this size tree, you have a node here, and then now you go, okay, well, is this your ancestor? I think I confused the movement, right? I used to know this. I don't know why today I'm so bad. Okay. I usually do it the other way, but anyway, okay, fine. Okay. So okay, so now just this big thing, and then if it's in there, then okay, we check the middle. Is it in there? Yes. If yes, or if what if it's a no? If it's no, then it has to be in the first half. So then you move up, right, and then you take a small chunk. This should be right, right? Okay, I mean. Okay, so the current number is 2. We go 0. It is definitely true, and because it's true. Okay, but then now we do it. All right, maybe I have to do. Okay, right. Oh, I did this wrong. Oh, I removed it, but then I forgot it. I'm confused about which version. This is still wrong for the other one anyway. LCA, this is right for LCA at least. This is actually, this LCA is right again. Okay, so maybe the LCA is actually right. Yeah, but not the final answer. Okay, so now you have you do want to do 1, 2. Man, my elbow, my shoulder is just so bad. Okay, so you have 1, 2. You want to get this chunk, right? And then from LCA perspective, it's just this and this. All right, I need some drawing, and if I'm going to do it, I might as well do it on screen. So give me a second. I don't know why I'm so bad today. this LCA part should be the straightforward part, but I don't know. It is what it is. Okay, so you have right. Okay, so we're looking for this node and this node. So then we have. So we're looking for. Oops. How the color changes? So we're looking for this node, which is now. So we're querying for this one and this one, which should give us. Oh, but Q sub. Oh wait, no. I'm debugging the wrong thing, but okay. Okay. LCA 211. LCA 1 is the LCA. Why is that wrong then? Because then now we basically subtract what we have here, so then we add this back in, right? Oh, we don't. I didn't add this back in. I add this back in. Okay. Because this is not Q of this. This is the value of the LCA. Yeah. Okay. Fine. What do I have? What do I call it? I think like I have a CS somewhere. Yeah. So it's something like CS of LCA or something. ID is equal to something like that. I mean, I fixed this one. It's 544, right? I think so. But then now this is wrong. What is going on in this one? It's just a thing, right? Why is this wrong? Okay, I mean the DP is right, I think. So then D of 1 and 2. LCA is not 2. So LCA is wrong. Why is my LCA wrong today? Yeah, I mean LCA should be 0 for all these 3 cases, so the LCA is just wrong. I give up a little bit, just in the interest of time, because I think I just probably have some typo somewhere. But what is an LCA Leetcode LCA form? I don't think I have it saved, the template. Maybe I do. Let me see. No, but I've. I'm trying to remember like the last time we have an LCA as a problem, because I really should put this in like a GitHub repo somewhere so I could search it. But nah, it is what it is. I mean, because usually I don't get it wrong. I don't get it. Okay, let's see if I could do one more check. How? Why is my binary search wrong? The DP is right. Okay, so zeros, yeah. Is this wrong? But this is just true the entire way, so it doesn't matter what I. Now I might fix wrong. This, but it's true the entire way. Am I just confused? Maybe I'm just confused. Okay, I am still very wrong. How? I really need to download my Leetcode things. I'm gonna just try Leetcode. Um, wait. Actually, this is still. Oh no. I just needed. Wait, what is going on here? Did I just not do DP? I guess that may be. So maybe the binary search is okay, but what did I? Huh. I am just. I don't know. It's. In case you're wondering, it's 3:44 a.m. So and I've been doing it for so long, and I've been snowboarding all day, so it's just very tough. Okay, so this is still wrong though, but I mean this, even the zeros are actually pretty bad, but that is still actually true for this particular input, so that's still not a reason. Leetcode LCA problems. Let's see. I'm just gonna find my template, or not template, just like code I've written in the past that used to work. All right. Leetcode binary lifting. I usually also write this another way, but still. My shoulder's got me. No, this. Oh. This is the cave ancestor. I can't find an example. I've written this, but. Am I forgetting something? I'm just trying to find my old code that works, and I can't even do that. Honestly, I am just. This is a struggle bus. That was so close. Sorry, friends. I'm a little bit tired. Okay, I found a code from my old contest where maybe I was less crazy. Let's see. DFS, okay, LCA. Classic lag. Maybe I don't do this. Maybe that's what I need. It would make it faster anyway. Okay, fine. Okay. Otherwise, okay, fine. Maybe I just missed this part, honestly, because I've written something like this before. So I guess this is the parents of this. But I mean, maybe that was it. I just forgot that I needed to do this. Maybe just maybe I'm missing a base case analysis. I didn't think I needed, but okay, fine. I have a print DP somewhere. Okay. Alright, let's hope this works. Because I really want to sleep. Okay. I mean, I think we got most of the concept. It took me like an hour and change to implement both the LCA and the thing. Well, an LCA, I mean, I had this, so I was right, but I just forgot about this. Like, this is what happens when you don't practice enough, I suppose. And it took me a while to remember this part for the ancestor. And then heavy light is not that bad. I guess I mean, I've never implemented it, so it looks way wonky. Maybe there's a cleaner way to write it. Let's see. I don't know. I don't want to quickly. Let's see if there's anyone legit on the leaderboard that I could look at, like real people code. From people I recognize instead of just looking up ChatGPT code, because I could do that without it. See anyone? I mean, I'm also going really fast, so maybe I'm just missing something. But oh, there's Alex. 23 minutes. Good job, Alex. What does this mean? Oh, I guess that's just code he copied from. And this is the LCA. Okay, fine. Copy the LCA code. Oh, he did it for Fenwick. I guess that makes sense because you're always just doing prefix. So you didn't need segment tree. But I mean, that part is not the hard part, right? Of heavy light. Yeah. Is there a way to look at this without like being in a little window? Why? I mean, my screen is already not that big, but even if I have a big screen, like, why don't you use it? Why are we making things look cool but not usable? Oops. Okay, so you have Fenwick, which makes sense. Oh, that is also smart, I suppose. I see what he's doing. So do the Fenwick on the Illudian tree, so then you can update all the nodes at the same time, I guess. I don't. Well, let me see if I can figure that out without looking at the rest of his code. Okay, so you have it already in Tor. you update all this, but then how do you get the don't they cancel out because you look at all the subtrees more than once if you just query for all of them? How do you do update and stuff? That I actually don't know. Huh. I mean, yeah, okay. I mean, do you just like figure out a way to do half? No, that doesn't make sense. Actually, I don't know. I mean, clearly there is a easier way, and that's what um, Alex did. But yeah, I mean, this is just counting the number of bits things, unnecessarily small. But okay, so LCA. He's not an idiot like me, but okay. LCA part makes sense. Well, oh, because it's the prefix, and everything on the prefix cancels out because you don't need to suffer. You don't need to. Okay. Wow. Okay. Yeah. I mean, okay. Huh. That's a really good way of doing it. I don't know if I would have came up with that one. I mean, I mean, even if you told me Orlidian tour, I don't know if I would have came up with it. Honestly, I don't think so. I mean, I don't know. Like if you give me an hour and gave me and told me it was Orlidian tour, maybe. But all right. I mean, Alex is smart. I'm not surprised. Yeah, but okay, that makes sense. Like I couldn't even come up with it immediately, knowing that it is Orlean tour and whatever, right? So I mean, well, some of it I just thought the Orlean tour is just used it for the LCA, but that makes sense. I mean, it's smart. That's a crazy. I mean, that's actually like a very cool way of using it, though. I mean, yeah, that's a very cool way. uh, I think I mean it is very specific to the problem, which is kind of nice and cool because it only works for XOR and this palindromy idea. But and the heavy light stuff is more general in that sense, in that like it applies to more stuff. But it's a ridiculous problem. But I mean, and I think if there wasn't the heavy light solution, um, this would be a very good fun problem, but it does get ruined by the fact that you can solve it with heavy light because heavy light decomp because that's what a lot of the people would do anyway. I imagine. I don't know. You know, I don't know if these people choose. Maybe not everybody. Apparently, a lot of people. Well, I also don't know what solution ChatGPT gives. So, you know, clicking on random people, I don't know if that means anything. Or like like this person probably seems to did yeah, this person did heavy light, right? Because I had light way for it. But yeah, I don't know. I need to I need a plugin so that I can only trust like trusted people or something. Because I don't know, looking at this leader list is just silly. Um, but yeah, I did not get this one. So but I mean, I don't know if I would say I gave up on it, but I did like with 40 minutes left. I with 40 minutes left, I kind of focused on learning. So if you told me that there wasn't, I don't know, like could I have got like if I have 40 minutes left and I knew it was Orient Tour, could I have gotten it? I don't know. I don't think so, to be frank. Well, I mean, there's not that much to do with Orient Tour, but definitely without the hint, I don't know if I don't think I would have gotten it. But yeah, uh, let's do a quick retro. I'm so tired. One was, oh, what did I do? Oh, yeah, one and well, two I just was lazy about, or I try to speed run it. And three is not interesting. But yeah, I mean, I took it as a time to learn heavy light decomp, and maybe some time when I take it off, you know, I'll look at how people normally do it, quote unquote, normally do it, and yeah, I mean, I think that's the thing, right? Is that, and I actually did forget some parts of the heavy light thing, and it's a very easy concept, though the implementation is very complicated, as you can see. At least the way that I did it. I mean, I imagine if you study a lot of it, yeah, if you use template, the template is created by someone very smart and they've kind of optimized a lot of things. But I did not, because this is my first time implementing it ever, for sure. Because it's like I've seen problems where I'm like, oh yeah, that's what you do, but I've never implemented it just because I don't know, never had the time or whatever, or just never got to it. And this is my first time implementing it. It's an interesting idea, and then it turned out I still need LCA, and that took me a long time as well. Today is just a very tiring day. But yeah. So none of them very interesting except for maybe Q4. But I think, honestly, I don't think this is an interview question. So it's kind of like, what are you doing, Leetcode? I mean, you and even I was gonna say even HLD, you need segment tree, which is probably already out of scope. So it's just a little bit silly. I know you can also implement HLD in this particular problem with yeah, with this one, you can actually replace this with segment tree. Oh, sorry, with binary index tree, and that would be fine. And maybe we can do that as a. Oh, okay, fine. I'm not, because I'm too lazy to kind of figure out how to navigate Leetcode's virtual contest weirdness. But you can actually drop and replace this segment tree thing, because this part is a binary index tree, but still binary index tree is probably still on the borderline of interview questions. So if you ask me, that's a little bit silly. And update is a point update, as I kind of messed this up a little bit in understanding. That one was on me, but yeah, that's it. That's all I have with this one. Let me know what you think. Thanks for watching. Yeah, I'm trying to move my bad shoulder. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.